plus iota sine theta 1. That is, modulus of Z1 becomes R1 and argument of Z1 becomes theta 1. Let Z2 be equal to R2 times cos theta 2 plus iota sine theta 2, where modulus of Z2 is equal to R2 and argument of Z2 is equal to theta 2. Therefore, Z1 into Z2, let it be equal to Z, becomes R1 R2 times cos theta 1 plus iota sine theta 1 into cos theta 2 plus iota sine theta 2. Multiplying we get R1 R2 times cos theta 1 into cos theta 2 minus sin theta 1 into sin theta 2 plus iota times sin theta 1 cos theta 2 plus cos theta 1 sin theta 2, which becomes R1 R2 into cos of theta 1 plus theta 2 plus iota times sin of theta 1 plus theta 2. This shows argument of Z1 Z2 is equal to theta 1 plus theta 2. That is, argument of Z1 plus argument of Z2. Note that modulus of Z1 Z2 also becomes R1 into R2, which is equal to modulus of Z1 into modulus of Z2. Let us now show how to construct Z equal to Z1 Z2, that is product of two complex numbers in an Argand diagram. Let OA be equal to 1 where A lies on x-axis. P represents Z1, therefore OP is equal to R1 and POX is equal to theta 1. Also let Q represent Z2, therefore OQ is equal to R2 and QOX is equal to theta 2. Draw QOR equal to theta 1. Therefore ROX is equal to theta 1 plus theta 2. Also make angle OQR equal to angle OAP, so that triangle OAP and triangle OQR are similar because two angles are equal. Therefore OA upon OQ is equal to OP upon OR. OA is 1, OQ is R2 and OP is R1. Therefore OR is equal to R1 into R2, that is modulus of Z1 into modulus of Z2 or modulus of Z. Therefore argument of Z is equal to theta 1 plus theta 2. Thus R represents the complex number Z1 into Z2. To find the argument of the quotient of two complex numbers, let Z1 be equal to R1 times cos theta 1 plus iota sin theta 1. Therefore, modulus of Z1 is R1 and argument of Z1 is theta 1. Let Z2 be equal to R2 times cos theta 2 plus iota sin theta 2. That shows modulus of Z2 is equal to R2 and argument of Z2 is equal to theta 2. Let Z1 by Z2 equal to therefore R1 into cos theta 1 plus iota sin theta 1 divided by R2 times cos theta 2 plus iota sin theta 2. We rationalize the denominator of the complex number, that we multiply and divide by cos theta 2 plus minus iota sin theta 2 and divide by the same thing. We get R1 by R2 times cos theta 1 cos theta 2 plus sin theta 1 sin theta 2 plus iota times sin theta 1 cos theta 2 minus cos theta 1 sin theta 2. In the denominator you get cos theta 2 whole square minus iota square, which will become positive sin theta 2 whole square. Therefore it becomes R1 by R2 into cos of theta 1 minus theta 2 plus iota times sin theta 1 minus theta 2 divided by cos square theta 2 plus sin square theta 2, which will turn out to be 1, or equal to R1 by R2 cos of theta 1 minus theta 2 plus iota times sin of theta 1 minus theta 2. Clearly argument of Z1 by Z2 becomes theta 1 minus theta 2. Theta 1 is the argument of Z1 and theta 2 is the argument of Z2. Therefore, argument of Z1 by Z2 is equal to argument of Z1 minus argument of Z2. Also here, Z1 by Z2 modulus is equal to R1 by R2, which is equal to modulus of Z1 upon modulus of Z2. To construct geometrically Z1 by Z2 in the Argand diagram, we have the following.